Okay, the number of right-handed students in a mathematics class is 9 times the number of left-handed students. This is a known thing by me, a left-hander. So the total number of students in the class is 30. How many right-handed students are in the class and how many left-handed students? So what we can do is say, first we need to identify the variables, okay? So let's say let R, I'm going to type this, let R equal the number of right-handed students and um, let L equal the number of. Okay, so here we go. We've got left-handed students on the x-axis, right-handed students on the y-axis. Okay, and there's no real one influences the other. It just happens to be you need one for one, you need one for the other. Now, okay, we know this really interesting fact. We know that if you take the number of left-handed students, oops, sorry about that, take the number of left-handed students and you multiply that by 9, that's going to equal to the number of right-handed students because there's 9 times more of them. So we can say R is equal to 9L. I'll take the number of left-handed students times 9, find the number of right-handed students. We also know this, that the number of left-hand students plus the number of right-hand students total is 30 because that's how many kids are in the. Okay, so because R is on the y-axis, we really can read this first equation as being like y equals 9x. Okay, and the second equation, we can read that as being x plus y equals 30 because R is the y. So the first one's already, we can graph this one right away, and we will in a second, but I'm going to do minus x to get our second equation, y equals negative x plus 30. Okay, so we're going to graph these two right now and see what we get. I'm going to pause it and I'm going to. Okay, so for the first one, I'm going to do the second one in blue. The first one you can see y equals 9x there. This is one of those direct variation equations with no plus anything at the end, so it's really a 0 y-intercept going through the origin. So I've started there at 0, 0, and I went over to 1, 9, because if x is 1, y is 9, 2, 18, 3, 27. I'm going to draw. All right, now I'm going to put a few points for this blue equation, and of course we have a y-intercept of 30 and the slope of negative. So there are some points, and I'm going to put a blue line. Okay, so then we're going to identify that point of intersection, and the point of intersection is 3, 27. 3, 27. And the x-axis is the left-handed students, so and the y value is the right-handed students. So it says how many right-handed students, how many left-handed students, and so we say R equals the number of right-handed students, 27. L, the number of left-handed students, equals 3. They sum to 30, the number of kids, and R is 9 times what L is. Now, I just want to, before I could wrap it up there, but I just want to say that you'll notice that I have a different graph for this one. How did I know what to graph? Well, one thing you need to understand is that you're not going to have a negative number of students, so I don't need the other quadrants. I need the first quadrant, which is positive for x and positive for y, and I knew that just by doing a little kind of mental calculation in my head that I was going to have to go basically up to 30, the possible number of students for y, and that was going to have most of the kids, so that would probably have to go most of the way up to 30. And for the left-handed students, I wasn't going to quite have to go that far because I knew there was going to be much less of those. But this is the graph that I picked, and obviously it fits because I gave it enough room to have all highest number of kids in the class, 30. So you'll get better at that, but we'll try and work on that a little bit in class if time allows.